Hello IS pilots and welcome to my flight training course, lesson 2, where I will show you the different ways to turn an aircraft. Before we start, however, we will have a look on how a turn actually works. In straight and level flight, as you might remember, we have the weight force pulling the aircraft down, while the lift created by the wings counteract to this force, keeping the aircraft in the air. Once we start to turn the aircraft, the weight remains vertical, while the lift bangs with the aircraft. Note that the lift still equals the weight. When we now once more split the lift into two separate vectors, you will see that the L1 force that actually counteracts to the weight is smaller than the weight, causing the aircraft to enter descent. Since we want the aircraft to stay at its altitude, we have to pull back on the elevator, causing the lift, and therefore the L1 and L2 force to increase. The lift is now greater than the weight, while the L1 force equals it. Thinking back to our first lesson, we can now ask the question, do we also have an equilibrium here? The answer is no. Sort of. It gets a little complicated now. Once we roll the aircraft into a turn, we destroy the equilibrium the aircraft had in straight and level flight. You see, the L1 force and the weight cancel each other out, causing the aircraft to remain at its altitude. The L2 force does not have such a partner. The plane is actually accelerated along the L2 vector, which always points towards the center of the turn. So far, so good. When you are sitting in a plane or car that accelerates, you will notice that there seems to be a force that pulls you backwards. You get pushed into your seat. This is because your body and any other object has inertia. That means that certain object has the urge to remain in its state of movement. That could either mean a certain steady speed or sitting on the ground with zero speed. In order to leave that state of movement, you have to apply a force to that object. Phew, physics. But don't worry, you have to know the stuff to turn an airplane. You choose for yourself if you want to know about that stuff or not. Back to our plane. The force you feel when you accelerate does not exist, however, we can use it anyways. It's just magic. Let me introduce two more force vectors to this picture now, and call them A and C. C is the force counteracting to the L2 force. I'm pretty sure you have heard of the centrifugal force before. The centrifugal force is an apparent force that acts on an object that describes a curve, when it really is the inertia that wants to keep the object at the current speed on a straight path. However, we need this apparent force to understand a turn. If we combine the C vector with the W vector, we get a new vector that counteracts the actual lift. We call it A. A is the apparent weight force that acts, from the aircraft point of view, straight down. It shows how much the aircraft apparently weighs during a turn. This is the G-force you feel. You will notice that if we banked our plane more and more now, we would have to increase the lift vector further, causing all the other vectors, except the W vector, to increase as well. This explains why the G-force increases as you increase the bank angle. I might need some coffee right now. Just one more thing I want to show you, and then it's off to practice. You may skip this part if you haven't already. How do I calculate the G-force? Now, given that the aircraft remains at its altitude and constant speed, the G-force depends only on the bank angle. Look at this triangle. The angle alpha represents our angle of bank, while A and W still represent the apparent weight and the true weight of the aircraft. The G-force equals A over W. Make sense? Now, when you roll out of a turn, A will equal W, and therefore you will have 1G. As you increase the angle of bank, A will increase, and therefore the G-force will increase. If we use simple trigonometry, we will get this second formula. Cosine alpha equals W over A. Or, turned around, 1 over cosine alpha equals A over W. Therefore, G equals 1 over cosine alpha. For example, in a 60-degree turn, you will pull 2 G's. It's that simple. Alright, enough with the science already. Let's fly.